Determine an expression for the general term, Tn, of an arithmetic sequence if the sum of the corresponding arithmetic series can be represented by Sn equals 2n squared plus 3n, where n is an element of the set of natural numbers. The general sum, Sn, of an arithmetic series is typically given by the formula Sn equals a plus Tn over 2 times n, where Sn is the nth sum, or general sum, a is the first term, Tn is the nth term, also called the general term, and n is the term number. Here we can use the formula that is given in this question for Sn to calculate S1. Note that S1 is equal to a, the first term, since the first sum is simply the sum of only the first term. From there are two methods. Method 1, we can equate the expressions for Sn. We can equate the equation for Sn given in this question with the typical equation for Sn in the formula given above right. We can then solve the equation for Tn in terms of n. For method 2, we can use the formula that is given in this question, Sn equals 2n squared plus 3n, and solve for the second term, T2. To do this, we'll first substitute n equals 2 to find S2, the sum of the first two terms. We can then subtract S1, which corresponds to the first term, from S2, which is the sum of the first two terms, and this will result in the second term. Once we have the first term and the second term, we can subtract them to determine the common difference, d. We can then use the formula for the general term of an arithmetic sequence, Tn equals a plus d times n minus 1, and substitute the calculated values for a, the first term, and d, the common difference, to express Tn in terms of n. First of all, we'll calculate the first term, substituting n equals 1 into the original equation given, 2n squared plus 3n, we get 2 times 1 squared plus 3 times 1. This gives a result of a, the first term, equals 5. I will first use method 1 to solve this question. Here I will equate the expression given for Sn, 2n squared plus 3n, equal to a plus Tn over 2 times n, substituting a, the first term, equals 5. We can now solve this equation for Tn in terms of n. To do this, we'll first remove the fraction by multiplying the entire equation by 2. This results in 4n squared plus 6n equals 5 plus Tn times n. In order to isolate the Tn, we will next divide both sides of this equation by n. The n's completely cancel out on the right side of the equation, and we can cancel out an n from the 4n squared and the n from the 6n. This results in 4n plus 6 equals 5 plus Tn. To isolate Tn, we would then subtract 5 from both sides. This results in Tn equals 4n plus 1. To solve this using the second method, we'll first figure out the sum of the first two terms, S2, by substituting n equals 2 into the formula Sn equals 2n squared plus 3n. This gives a result of the sum of the first two terms of 14. To figure out the second term, we can then subtract the second sum minus the first sum. This gives a result of 14 minus 5, so the second term is equal to 9. Now that we have the first term and the second term, we can determine the common difference by subtracting the second term minus the first term, giving us d equals 4. Now that we have our common difference and our first term, we can substitute these into the equation for the general term of an arithmetic sequence. Tn equals a plus d times n minus 1. Substituting a equals 5 and d equals 4, we can then solve or simplify the right side of this equation, giving us Tn equals 4n plus 1. The same result that we got in method 1.